Hi there, Mr. Sutton here, bringing you this Pre-Cal Honors 4-4 lesson on laws of logarithms. In this one, we will be simplifying expressions using these laws. So, for example, the log of a product or a quotient, and also the log of an expression that has a power. In a moment, we're going to show you 3 laws of logarithms. To grasp the intuition behind them, as a warm-up, pause the video and simplify these 3 exponential situations. All right, let's see what we got. For the first one, we're multiplying bases, so we have to add the exponents. The next one, dividing bases, we have to subtract the exponents. So this is b to the x minus y. And then for this last one, we just multiply the exponents together, b to the xy. So multiplication becomes addition of exponents. Division becomes subtraction. And then exponentiation itself becomes multiplication. So you could kind of think of this as everything becoming sort of one operation simpler. So now here are the big 3 rules of logarithms. And take a look at how these stack up to these exponential problems here. If you're taking the log of a product, multiplication is going to become addition. We're going to rewrite this as the log of x plus the log of y. If we're doing log of a quotient, division is going to become subtraction. So this is log of x minus the log of y. And then finally, if you're doing the log of exponentiation, that's going to become multiplication. This y is going to come out in front as a coefficient on the log of x. In fact, this particular little rule, I gave its own name. I call this the pop-out rule because the exponent pops out in front of the log. Now that we've seen where the laws of logarithms come from, let's see if you can apply them to split these expressions up into individual logs, by which we mean we're going to have expressions with just log x and log y instead of log of all of this stuff. All right, let's see how that first example went for you. So since we have division inside a logarithm, we can split that up into the subtraction of 2 logarithms. So that's going to be log of x to the 6th minus log of y to the 3rd. Now we have almost what we need here, but we've got some exponents that we don't want inside there. So for each of these, we're going to use the pop-out rule and move the exponent out front as a coefficient. So for this first one, we'll have 6 times log of x minus, this will become 3 log y. All right, let's take a look at the next one. So for this one, we have multiplication inside a logarithm. So we're going to split that up into addition of logarithms, and ln is just a normal logarithm, where it's a different logarithm. So we can use the same rules that we used over here with ln. So this is going to be ln of x plus ln of the 5th root of y. Now we have to take care of this exponent over here. Since this is really just y to the 1/5 power, we can break this up into ln of x plus, and then this will be 1/5 ln of y. For the next 2 examples, we're going to go backwards and take a couple log expressions and merge them into a single log or a rational number if we're able to simplify that log. So pause the video and see if you can work backwards to move these 2 expressions into one big logarithm. All right, let's see how that went. So a good strategy to use is to start by popping in the exponents in the beginning. So we're going to have log of x to the 9th minus log of w to the 1/3, which we could also write as log of cube root of w. Next, we're going to deal with the add or subtract by either multiplying or dividing the stuff inside the logs. So in this case, since we're subtracting the logs, that means we can divide the arguments to the logarithms. So we can write this as log of x to the 9th divided by cube root of w, all inside one big log. All right, pause the video and see if you can deal with this next expression here. All right, let's see how this went. So we start by popping exponents in, just like we did up here. So this will become log of 5 to the 4th and minus log of 5 to the 3rd. Next, we're going to go ahead and merge this all into one big log using the add becomes multiply and subtract becomes divide rule. Now, if you have a long string of logarithmic expressions like this, you can actually think of this as ending up inside a big fraction inside a logarithm, where the numerator has all the positive logs, or at least the arguments to the positive logs, And now in the denominator, we're going to have the arguments to the negative logarithms. So in this case, we end up with the log of positive log of 2,000 and positive log of 5 to the 4th means these are going to be multiplied, 2,000 times 5 to the 4th in the numerator. And now since we're subtracting log of 5 to the 3rd, that ends up getting divided into the denominator. At this point, if we can simplify the expression we need to, so I notice that I have a 5 to the 4th here and a 5 to the 3rd. Dividing, I can subtract those exponents. So this just ends up being 2,000 times 5 to the 1st, which is 10,000. And if I have log base 10 of 10,000, well, just count the zeros here. That's just going to be 4. On these last two examples, we're going to deal with the situation of what happens when you have more than one thing inside an exponent and there's a logarithm involved. So if this were just 10 to the log of 2, we'd know how to deal with that. We would just cancel the 10 and the log and we'd just end up with 2. But since we have this 4 out front, we need to start by popping coefficients in the logarithm before we cancel the bases. So pause the video and see if you can figure out exactly how to do that. All right, so this should end up being 10 to the log of 2 to the 4th. We're going to pop that 4 in as an exponent. We know 2 to the 4th is 16, and then the 10 and the log base 10 cancel, leaving us with just plain old 16. Now, for this next example, this one's a little bit trickier. We don't want to have all this stuff inside the exponent. So the way I'm going to handle this is I'm actually going to unsimplify by unadding the exponents and turning this into multiplication. So I'm just going to write down my next step, and then we'll explain why it works. We'll kind of explain backwards here. So I'm going to rewrite this as e to the 14th times e to the ln of 8. Now, let's just pause for a second and see if this makes sense. When I multiply the same bases together, I'm allowed to add their exponents together. So if I were to multiply these, I would end up with e to the 14 plus ln of 8. But now I just want to go backwards and unadd them by reestablishing this multiplication. So what does this get us? Well, e to the 14th, we can't really do much with that, but e to the ln of 8, that's just going to be 8 because e and ln are canceling out. So I can simplify this to just 8 times e to the 14th. So that's it for this lesson on laws of logarithms. Make sure you follow the rules on the homework. Till next time, Mr. Sutton signing off.